Greetings everyone and Happy New Year. My name is Yasen Stoykov and I want to welcome you to this very first Ontotext webinar for 2022. This community that we've built here is very appreciative of us, and we hope that we will continue this in this year as well. All of these webinars, all the people that join, it means the world to us, and we want to thank you for that. With that said, I will take just a few minutes to present the speaker today and to go over a few housekeeping details that I think are important. But first, the speaker, Radostin Nanov, who is here with me. Hi, Rado. I hope you don't mind if I say a few words about you.
Not at all.
I thought so. So, yeah, Radostin has a master's degree in software engineering from the University of York in the UK, and he has been on board in Ontotext ever since he graduated in 2016. He is the core maintainer behind the Ontotext Cognitive Cloud, and he also doubles in DevOps, helping to spearhead Kubernetes development in Ontotext. When he gets the chance, of course, he participates in the core GraphDB development as well. It's short, but with that said, I will quickly go over a few details as I mentioned. So first of all, you are all muted. This is for practical reasons, but also to enable Radu to present without any interruptions. This doesn't mean that you cannot communicate with us, not at all. You can do communicate with us via the chat box. You can ask questions, and actually we strongly encourage you to do so in order to have a meaningful discussion at the end when we will have this Q&A session. So yeah, this session is also being recorded, so you will have the access to the recording probably tomorrow or early next week at latest. With that said, I will give the stage to Rado. Rado, I can't wait to hear what you are going to present to us. Good luck, and the stage is yours.
Hello, everyone. As Yasen already said, my name is Radostin Nanov, and I have the honor to present from disparate data to visualize knowledge, which is all about how to grow your data organically and to start at data and arrive at knowledge. We're going to discuss Kafka, RDF mapping, how to tie analytics and complex ETL steps to your data in this webinar. This webinar is based on a series of blog posts which we made over the past month or so, and there's 3 of them. You can probably find them on our website, and this is just the distillation of it in 45 minutes or so, I hope, because when I was testing it out yesterday, it turns out that it's a very broad topic, so we're going to be touching a lot of information relatively briefly. Fortunately for you, all the information which we can touch briefly upon, we've expanded in our documentation. We have blog posts on it, we have white papers and other webinars on the topic. You can access all of that on our website. So essentially, I'm going to be giving you a very quick introduction to our capabilities here. So this is the presentation outline and what we're going to go through. The first step is essentially a introduction. And then we're going to go through the different steps which correspond to different parts of the blog post. And finally, we have a Q&A session. Now, this is mostly going to be relatively technical. But before we start with the technical details, I want to ask you, and you don't need to answer in the questionnaire there, but still think about it. What comes into your head when you hear the word revolution? Many of you are technical folks, I assume. So you think maybe about the World Wide Web, maybe about the industrial and technological revolutions. Well, if you're trendy, you may even think about blockchain, because that's the most current revolution, so to speak, or at least most people tout it as a revolution. And that's great, that's a valid definition, that's a worthwhile definition of the word. But as a fan of history myself, you probably can figure out what I'm thinking about first when I hear the word revolution. That's what usually comes up in my mind, and the search engines agree with me. It's not the World Wide Web, it's not Google, not even the agrarian or industrial revolution, even though those are exactly revolutions. The pace was quite slow. It's about upheaval and rapid, dramatic change. So I'm going to talk about evolution and revolution. So both of those are changes, and both of those have their place. They're useful and worthwhile things. But here and in this on this topic and in this presentation, we're going to talk about evolving our structure. So you've probably heard that at least a few times in the past few years: disruptive technology that will change the market forever. And revolution is all about this, about quick changes and new paradigms and completely reinventing yourself. We're not going to do that right now. We're going to talk about how you start from something basic. We're going to start from an analog solution actually, and bring it all the way down to digital solution, which integrates with other digital solutions. So revolution, what about that? Well, it's sudden. It does not work well actually with the agile manifest with the agile principle, because if you think about it, revolutions are leaps of faith. You need to know, you need to prepare many things because it's a sudden change. You need to it's disruptive to the technical model which you may have in your company and your business. It is a leap of faith which may work out or it may not, and it's great when it actually works out, because occasionally revolution is needed. If you think about the World Wide Web, French Revolution, Industrial Revolution, when it works amazing. It's bringing the people what they need when they need it. Without the Industrial Revolution, we'll be, without the French Revolution, we'll still be living in absolutist monarchies, and without the World Wide Web, well, actually, it's sort of easier for me to imagine the French Revolution failing and us living in absolutist monarchies than not having the internet at this stage. But when it fails, a revolution fails, well, spectacularly. In terms of technology, and I'm going to drop talking about historical terms now, but in terms of technology, you can think about Segway, Google Glass, which were both touted as revolutions, or at least they tried to position themselves as revolutions. They didn't, Segway wasn't bringing the people what they needed or wanted, actually. And Google was just, Google Glass was pushed out way too early. And revolution is always disruptive. So just like political revolutions. And automation, which is happening at the moment, is another example. People are losing their jobs. Automation is great, but it leads to losses in the workforce. And that's a problem. Even a failed revolution like Google Glass will be disruptive. There will be loss of revenue, there will be some loss of productivity, etc. Evolution, on the other hand, what we're going to be talking about mostly, it is literally building better. So you take something, you iterate upon it, gradually it becomes a better thing. In the natural world, better would mean better for passing on its genes. In technology, that means more useful or more profitable. In this case, we'll be focusing on more useful, and this would bring about profits as well. One example in technology would be YouTube. As you probably all know, and you've used it in the past, YouTube changed a lot. Recently, they removed dislikes. The website changed styles many times. Probably they did that as a revolution, and all of a sudden said, okay, so now you have more ads. We're going to change the design. We're going to remove dislikes. There would have been a massive loss of usage if it was a revolution. So you can see here that gradually changing things is better. Sometimes, of course. It's all about gradual deprecation and backwards compatibility. You can think about Microsoft, and their backwards compatibility goes way back in terms of designs, especially. If you dig around Windows 10, there's still Windows NT and Windows 3.1 menus. And no one ever opened Windows to find out they got their workflow completely removed and it's not there anymore. Some of the workflows were changed, but again, it's a gradual change. And of course, it can be outpaced. That's the problem with evolution. Sometimes you need that leap of faith. Sometimes you need that clean slate. As programmers, we love that clean slate because it means you can try a new technology in a better way without old code to deprecate, but sometimes faster movement is needed. And I was mentioning Windows, that's actually Windows 11. I need to update my knowledge on the topic, and I dug for that picture a worrying amount of time to find it out. That's Windows 3.1 menu inside Windows 11, and I actually found another old feature from the Windows times, which is this. You can close by double clicking on the top left and your Windows Explorer or Windows apps. Didn't know that. Apparently it was in Windows 3. And another thing is, for example, the compatibility check in Windows 11 and all Windows versions. There's the game which was released around 2000 called Barbie's Racing Club. Each time when you start a Windows application, one of the first things which it asks is, are you one of those old programs? By the way, are you Barbie's Racing Club? Because if you are that particular program, I need to do it. I need to do some specific actions because it needs to run in compatibility mode. And yeah, Windows is evolving. It's not doing revolutions, and people may dislike it because of that, because it's not removing some old features which were useless or not liked. But they keep going back to it. They keep using it. And now we're done with the introduction, and we're going to talk about our use case first. It's about building compliance, which is an interesting topic which has a lot of importance because everyone wants to be certain that the buildings which they're using, they're well built and well designed and safe and secure. It's very formal. There's a lot of standards there. There are standards for each area. There are standards for each country. There are standards for each super country organization like the EU, for each union in this case. It used to be done manually. You would have a person coming in with a checklist, and they would be going through the checklist and inspecting different parts of the building and inspecting your documentation. Now this is moving towards automation, and we're actually going to discuss how it happens with drones and how it happens with automatic checks on the data which is being input. And it's built on spreadsheets. If you go into a building compliance situation and you need to check something, you need to have some paperwork done, there's going to be a spreadsheet involved. And spreadsheets are great actually, because almost everyone knows how to work with one. And anecdotally, about 12 years ago, when I was in high school, we were actually being taught spreadsheets. We were taught how to do things there. And this is 12 years ago. Nowadays, I'm quite sure that people in secondary school probably have an idea how to work with a spreadsheet. There's an incredible amount of tooling. Of course, many solutions by Microsoft themselves, solutions by Google. Like you can see that this is being run on Google Docs, actually. Just like that, they have Google Spreadsheets as well. You have SharePoint, Microsoft Office, variety of open source tools for working with spreadsheets, and also working with spreadsheets programmatically with pandas and Python, for example. You can spreadsheets can be analog actually, and this is part of the great design point of them, because many things which have great design and which we consider great design, you take something from the real world, you take desktop in my case, for example, and you build the concept of the desktop in terms of the desktop which we have on the computer. And at least this is how it goes. And also spreadsheets, they just translate it almost directly. We don't want to force our users to stop using spreadsheets. They know how to do it. They like doing it. Spreadsheets are useful. They have great tooling. Do we want to turn around and tell our users, we have a revolution. You no longer need to use spreadsheets. We have this awesome new other thing that you're going to use. We can, but probably no one's going to like that. So, modeling semi-structured data on OntoRefine. First, GraphDB, as you are probably aware, it's RDF database, and it works with triples. So it's working with subject, predicate, object type of triples, which you're able to tell that someone is something. So for example, Radostin type person. That's the subject predicate object triple. And our data is semi-structured. So we have a spreadsheet which is CSV, TSV. So OntoRefine also works with XML. It can be exported as some structure. You have columns, you have rows and identifiers. And there's a tool in GraphDB called OntoRefine, and it's based on OpenRefine. So it's open source. We love open source. Some of our products are open sourced as well, or at least parts of them. And OntoRefine allows you to take that spreadsheet, take that semi-structured data and turn it into RDF, which is, again, not as structured as SQL, but it's more structured. OntoRefine has a very powerful UI and it can be easily automated. So in fact, I can go back a bit, go forward, sorry. This is the UI of OntoRefine. Now, unfortunately, I was trying to do that with a live demo, but when I tried to do it with a live demo, it turned out that I ran out of time. So unfortunately, we're getting screenshots, but you can probably believe me that I did this manually and just took the screenshot for it. And here you see how it looks like. So you do some actions, and all those actions here I've done to essentially modify the incoming data and to transform some of it. And then all those actions, you have them in a JSON here on the right. You are able to get the list of those actions, select which ones do you want, and then you get the JSON and you can extract that as a file and apply that to other spreadsheets, which we get later, to other data sources. And I'm saying spreadsheets a lot, but OpenRefine is actually versatile. OntoRefine is actually versatile. You can do it with XML, again, CSV, TSV, many different other formats as well. You can go into it, play around with it. As I said, the UI is relatively intuitive and it's easy to automate. In fact, going back to this slide a bit, in fact, it has command line tools now. That's a relatively recent addition. I believe GraphDB 9.10 now comes with a command line tool which you're able to easily tell, okay, that's my data source, that's my those are my transformations. Please apply those transformations to that data source and give me the output. And you have a simple mapping language. So for example, I'm going to give you this example, which we're mapping some literal, and we have in the data source something cells with longitude and latitude in this case. So we're going to take that, and this is the transformation which we're going to apply. This is expression language, Google expression language. I think it's what means GREL. I'm going to take that information from the cell longitude. You can see it here. In fact, I don't think that my mouse is shared, but you probably can check out where it is there in the middle, relatively the GREL, where it says use value row cells or recon record. There's the cells. I'm going to pick up the longitude, replace a comma with a dot because we like dots for this purpose. And I'm going to put that in an OpenGIS format because I want to have a point. And GraphDB supports the geospatial and geosparkle standards, and you can do operations on points and on objects, polygons. Like you can ask, is this point within this object? So, for example, for checking where street is located. And then I'm going to say that this, which I've picked up from the cells, is literal. So I'm going to say that that's a WKT literal. And here, minor thing which I wanted to mention is recon. You can see there on the left that it's happened. This allows you to reconciliate some data which you have with some knowledge which you have, with some RDF which you have. So, for example, you have the word here. Let's go with that. AT&T, which is a corporation in the US, and you're able to tell it, okay, I have this text, I have those supporting fields. I know that it's in the telecommunications industry. So please give me an ID for this text to match it to my data. It's going to say, okay, I'm going to suggest that you match this to the AT&T company. And this is also one of the Ontotext's products. It's not shipped together with GraphDB, but it's a product which we have. And you can have custom reconciliation from Elasticsearch. So inferring new data. If two buildings share the same address, then they're the same building. As of now, we still cannot make buildings fault on top of each other. It's going to be a very fancy thing once it comes around, but it's not possible yet. This can be done with RDF same as. I'm going to say that ID1, and the ID1 is of building 1, is the same as ID2 and ID of building 2. You can do this two different ways. You can do it with the building core rule set and an ontology, and you can do this with a custom rule. So those are the examples. So you can use a custom rule to infer that the buildings sharing the address are the same. So I'm going to say that X, that has the type of building, Y, that has the type of building as well. If X has the address Z and Y has the address Z, then X is the same as Y. And this is useful when we cannot use an ontology and when we want something deeply customized to our own particular use case. And inferring new data, we have all of that data explicitly, which is above the dotted line. And the data which we have on the bottom, the database will automatically come up with that. It would automatically know that X is the same as Y. You don't need to manually tell it. It just knows that because you have the rules from which it can decide that X is the same as Y. Now, this is good, but maybe we want to use a built-in rule set because this is only specific to our use case. This is something which we have to do custom, and GraphDB actually allows any sort of statement pattern here, and it's relatively versatile in that way in which rules you can set up. But maybe you want to use a built-in rule set. So we can do that with the owl rule set, like the bird. That's the first part of it, because I don't think I'm pronouncing it properly. And we can use the inverse functional property, which is saying that that's a property that defines an inverse functional relationship. So the data which we have in our database here is that A has the type of inverse functional property, and BAC, so for some subject, uses that predicate A, uses some object C. And DAC, we have D uses that predicate A, and C, it has the same object. So this is saying you have two triples, they have the same predicate, they have the same object, but they have different subjects. Then, and the subjects are not the same. Like explicitly it says that B is not equal to D. And then because we know that this predicate is an inverse functional property, the database will automatically infer that B is the same as D. That's essentially the same rule as above, but this is more generic, and this is highly specialized to example building. In order to use the more generic rule, which is part of the built-in OWL rule set, you define that example address, that's an inverse functional property. Building 1 to 3 has that address on street. Building ABC has that address on street as well. And then the database automatically will know that building 1 to 3 is the same as building ABC. Data quality, that's a big problem because everyone makes mistakes, and we don't want to have mistakes because, as we said, automation of building compliance is really important that we get things right. SHACL is a language that's a W3C extension on top of RDF databases, and it allows you to define some specific rules. And those specific rules, you can use those to check your data. So I'm going to go forward a bit, and I'm going to show you an example. And those are some rules. Lazy, and you can check all about that in the blog post. That's the name of our example organization. So it's some acronym which I came up with for the samples. So we're going to say that the compliance report shape that has a target, and the target needs to use that predicate built by, and has value needs to be Acme Corporation. So that suggests that we're going to check all subjects which have been built by the Acme Corporation. So this would be many different types of buildings, and actually, if we have built by Acme Corporation for an anvil, for example, it's also going to check the anvil, which is probably wrong, but it depends how you set it up. In this basic case, it's going to check anything which is built by the Acme Corporation. So in this case, it's checking on the path lazy address. So this subject, which is a subject that is built by the Acme Corporation, if it has it needs to have at least one address. So minimum count is count of one, and the date it needs to have a date. So sorry, it doesn't need to have a date, but if it has a date, if it does have one, the data type of that object needs to be an XSD date. So it shouldn't be an year, it shouldn't be a string, so it cannot be someone just writing all the year 2000. It needs to be specifically a date, and we're going to define that the date is going to be the year 2000, 1st of January, because, for example, that's when the Acme Corporation is founded. That's how a SHACL shape looks like. You provide that in a specific graph, and then all your data is checked against that shape. There's a focus on performance and iterative validation. So I believe that RDF4J, which is the underlying framework on which GraphDB is built up, it is the major iterative solution for SHACL, and from the ones which I've tried, it's the iterative one, and it has a better performance due to that, because you're able to check only the data which comes in. So, for example, what I mean here is, let's give you an example of an iterative information. So new building comes in, and it's built by the Acme Corporation, but in the update, we don't have information about the address. What's going to happen is the SHACL engine is going to go through our data and check that, okay, we need for the Acme Corporation building, we need to check lazy address, and we need to check lazy date. Okay, we already have lazy date in our update, so that's good and it fits, but we don't have address, so it's going to query the database, pick up lazy address from the database, and going to check that there's only one result. And this allows us to be more performant, because we don't need to always check on everything. It does mean that there's less flexibility sometimes. So this is our architecture at this point. We have a building inspector who writes a spreadsheet. There's a data analyst who says, okay, I want to move that spreadsheet through OntoRefine to the database. There's going to be inference happening. And on the inferred triples, we're going to check that with SHACL, because SHACL works on both inferred and on explicit triples. That's how it happens. First things are inferred, then they're checked and validated. So moving on, resilience and automation. For example, we are successful. That's amazing. If a system is successful, many people would adopt it and they would pay us, or if they don't pay us because it's an open source project, they are going to use it and spread the word and generate usage data for that project. Is going to become more popular. There's going to be more developers. It's going to be more useful to people. But when more people use that, and there's going to be more building inspectors around the place, there's going to be more people clicking that button and saying, okay, so start inferring data, start the import process through OntoRefine. And manpower is expensive. It's expensive to get a person out there in the rain and in the cold with a spreadsheet and the hard hat going through and checking all the things. And probably that person also doesn't like being out there in the cold and in the rain. So you can automate building inspection, actually. There was an European project which we were involved in about automating building inspection. That's actually how I came up with the idea to base our use case around that. And it's all about using drones, rovers, and flying drones and satellite imagery to make sure that the buildings are proper. And of course, there's also documental checks. Also, people can come in place and do their spreadsheets, but there's drones, and those drones communicate with the system. And system outages, usually when we speak about manpower expensive, it's expensive for someone to come up and say, okay, this system went down, I'm going to get it back up. That's expensive and it may not work, and this person may want to sleep at night, which is nice. And the outage may happen in the middle of the night, and all of a sudden someone on the other end of the globe, they're in the working day and they want that information. It's not there. What to do? Well, we still keep people in the driving seat, but we provide them with the tooling, so they don't always have to be on the building site or behind the monitor in person all the time. So ingesting data from autonomous actors. Autonomous actors is the drone in this case. Autonomous inspection drones, we can call them. They're flying, they're quadruped, they're rolling around. There's standard formats for drone messages. They're actually being agreed upon around this time. The area is becoming more and more standardized, but we are quite certain that it's going to be some sort of Java message, which we can easily feed with Kafka queue. In a Kafka queue, and GraphB ever since GraphB 9.8, I believe, or maybe a bit wrong, maybe 9.9, it allows you to automatically pick up that Kafka queue and have the messages from the Kafka queue and produce RDF based on that. Unfortunately, it's not extremely flexible. You cannot use it in a filter, for example, directly. We hope to get there. Actually, there's a specification and ongoing plans that we're going to use a templating language, and you'll be able to plug in fields from the Kafka message anywhere in your query. But at the moment, it's more basic. Like you need to have a predicate object pair inside of that Kafka message is going to pick it up. But that's not a problem because we can do custom ETL with the GraphB API. GraphB has plenty of APIs. It has, of course, the RDF4j Java API. We have a custom GraphB API built on top of that with some extra functionality. We have, on top of that, we have JavaScript API. We have, we don't have a specific API for GraphB in Python, but you can use RDF lib, you can use .NET RDF. It's powerful and versatile ecosystem built around RDF data. So, and this is some part of a Python script because this is data analysts who will probably be doing that and data people, and they love Python, and that's good because we also like Python. It's a versatile and relatively expressive and easy to use language. So you probably don't want to go through that script right now, but it's going to be there in the slides and notes which we send you if you're interested in how it looks like. That's using RDF lib in Python. So when things go wrong, because things inevitably go wrong every now and then, maybe there's a power outage, maybe someone's toddler was playing around on the keyboard, maybe there was data corruption. Things go wrong occasionally, but there's the GraphB cluster. We don't want the person to come in and do things manually. So we have a cluster which is a replication cluster. So we have 1, 2, 3, 4 workers on any amount of workers which configure there, and those workers replicate their data. So each worker has the same storage of data, and in the case that one of those workers is destroyed, so it can be literally destroyed, someone can take a hammer and bash on that computer, one of the other workers is going to be able to pick it up. We also recommend regular backups. There's an incremental backup functionality as well as a complete backup functionality in GraphB. A complete backup happens slower, but it takes more storage space because it's a dump of the entire database, whereas an incremental backup just looks at what has changed, then writes down only the changes. Of course, it takes longer to perform an incremental backup because you have to calculate that difference. You can deploy with Docker, Kubernetes. We heavily recommend that, deploying with Kubernetes, because you have liveness checks, which are automated for you. You have rolling updates, you have easy blue-green updates. And because we like Kubernetes, we like the functionalities which it provides, we have GraphDB Helm on top of that. Because it's a bit hard sometimes to replicate Kubernetes deployments, GraphDB Helm allows you to move forward with that. So you have a templating language. In this templating language, you say, I have those and those and those values which are going to be specific for this deployment. Please, can you have the same deployment repeated? And that's what the values file looks like. And the values is sort of the configuration file for GraphDB Helm template. For Helm templates, just in general, it's not a GraphDB specific technology. Ever since GraphDB 9.7, we've started releasing GraphDB Helm as well. And it's an official Helm chart. I believe it's on the Helm repository as well. So here we're defining that our user is admin, their password is root. That's the default. So no worries, we're not sharing any vital data. We're going to say that we want to store our data. So we don't want just Docker containers, because Docker containers are ephemeral. When Docker container is removed, it loses its data, unless if you say that you want to store it. And here we've said that we want to store it. We enable security. This is some internal information, like how we're going to configure security with the provisioner username. There's a small tool which goes and does security for you. We're going to enable the API gateway. There's the db-conf config map for the API gateway. You're going to say that you need 2 masters and 3 workers. And you're going to use read, write, and read only. So the primary master is going to be read, write, and the secondary master is going to be read only. We're going to say that, yep, 2 masters, 3 workers. There's different config maps for the repositories, and the config map in this case probably just contains the repository configuration. And you're going to limit that with some resources in terms of memory and how much storage you're going to give it in persistence. So this is how our architecture looks at this stage. That's how it has evolved. We have the autonomous investigation drone, AID. It produces some report. There's the Kafka cluster, which stores the messages inside queues. They're being consumed, those messages, by ETL cluster, which is the extract, transform, and load data, which updates the GraphDB cluster. There's queries going on as well. And this is because maybe we want to do updates depending on what we already have in the data. So, for example, if a building has been checked in the last year or so, then we need to update that the latest report is this one. But if it hasn't been checked in the last year, we want to flag it as not checked, things like that. And there we have the GraphDB cluster and its resilience layer, so to speak, with multiple workers. So working with other systems and visuals as well. So there are thousands upon thousands of visualization systems. There are thousands upon thousands of data systems. It's a tremendous amount of systems. Now, we would have liked if everything was RDF and if everything was inside RDF formats. We would have loved it if Ontotext and GraphDB could serve any sort of data all out there in the world. It would have been awesome. It would have generated us a lot of revenue, but we are specialized in RDF, and RDF has its strengths, has its weaknesses. We don't want to integrate all the data. Our system is one of many, and this here and here I'm referring to the system in our example, the building compliance system. It's a lot of part inside of an ocean of data, and some of that data is relevant, some of it isn't relevant. There are other systems which do the same. There are other standards which do the same, and maybe we probably want to integrate with them. We need to be able to interact with those systems. And also, the final point, we need to have good data visualization, because SPARQL or plain SQL queries or whatever we like, that's not that's not great for analyzing data, because I love working on the command line, for example. I love command line tools, but I still use a GUI from day to day. I still use the graphical interface on my computer. Doesn't matter how much I love the command line. I'm more productive if I have a graphical interface. And developing an internal-only system that can be viewed by non-specialists, that's the end which we want to evolve out. And we're going to do that with, first we're going to start with federating with other systems. We're going to cover SPARCL federation. So SPARCL is the SPARCL protocol and relational query language. And it's a reflexive sort of the definition it contains itself, recursive sort, not reflexive. And SPARCL that suggests that you can talk between different RDF databases which implement the same SPARCL standard. So we have an RDF database, we can easily interact with other SPARCL systems. There's internal federation, there's external federation. So internally, this is federating between different repositories within GraphDB. So we have the different data silos within our implementation, within our tool. And then you can say that you want to talk internally between them, and this offers better performance because you don't go over the internet, you don't go over HTTP. External federation is the same, only you go over the internet. So it's, for example, Wikidata. There's Wikipedia. It's stored as RDF system as well. There's RDF mirror, so sort of Wikipedia, and it's accessible with federation. So anything out there, you can pick it up with external federation. There's also FedEx federation, and I'm going to explain FedEx federation with the next slide. So here we have a federated query, and it's using only internal federation. So we're asking about the building, its location, and its standard. And we're asking within the building repository. So the building must have the type building. We're going to pick up its type here. And it needs to be located in some country. Then we're going to move to our geolocation repository. Using that country information, which we picked up from our building repository, we're going to pick up the label for that, the location. Then we're going to move on to our standards repository, which is also on the same installation of GraphDB, or it can be remote if we were using external federation. In which case here, instead of service repository standards, we would say service HTTP IP port repositories standards, like we'll have the URL to that repository. We're going to say that within the standards repository, there is a standard which is originating within that location, which we pick up from the geo repository, and it's for that building type which we picked up from the building repository. And it's going to feed that information, and it's going to end up with this wonderful data that we have a building that's located in this particular location and has this specific standard, incorporating data from 3 different repositories. And oh, sorry, I was mentioning that I'll talk about FedEx. FedEx is related to the fact that here you see that we're defining all those repositories manually. So we know that those 3 statements on the top, building, lazy type, lazy country, they're within the same repository. We know that the other information is within the geolocation service. We know that the standards information is within the standards repository. We need to know all of that stuff beforehand. If we use FedEx, we're able to say, okay, so FedEx does that for ourselves, picks up the information, and just says, okay, so this is from the information from the building repository, and I know that building has those statements. This is because we use label. Oh, you use label, lazy label. That's located in geolocation repository, so it's going to move it there. And you are asking about lazy origin and lazy building standard. Oh, I know that this is located in the standards repository, so I'm going to send that query to the standards repository. And this is great because it allows us to write a simpler query. You don't have to define security also as well, because if we're using a remote endpoint, we have to write out what's the username and password. But of course, there's a small drawback because you need to do it. Essentially, FedEx does that thinking for you. It does that logic of breaking up the query in different parts. Of course, there's an overhead because it needs to carry out that splitting of that query. It has to carry out that integration of the query later on. RDF to anything. Well, we would have loved it if it was truly to anything, but it's not actually to anything. even though, of course, using RDF, you can expose it in some standard which translates to some other standard. But RDF to anything is easier than writing RDF to SQL to GraphQL to know our different integrations. We have, because we know that semantic data and RDF is not the be-all end-all, we can translate it in other formats. We have a SQL service. So you have your data in SQL, you can have that information in RDF as well. So we have an on-top virtual repository, and the fact that it's virtual means that the queries are translated. So the queries are kept inside the SQL database, and they're just being processed with RDF. We have the reverse as well with the JDBC driver for GraphDB. You can write your SQL, which connects to your RDF service. We can have GraphQL to RDF. So you can write out your GraphQL, which is graph query language, and you can pick that, and the GraphQL query gets translated to an RDF query with the Ontotext platform, and then you can have GraphQL federation. And you can also have SQL federation as well. Onto mapping for RDF. So that's an example of how to configure an on-top repository. So here I'm going to start from the bottom. There's the source. We're going to select everything from the inspections one. This is their database. The inspection table. And we're going to filter that a bit. We're going to say that we only care about completed inspections. Okay, then we're going to translate that into RDF. We're going to say that there's a report ID column inside the inspection table. We're going to use that for our ID in RDF. There's also an @date column within our inspection table. We're going to use that for the date of that inspection. And this is our data in RDF, how it's going to look like. It's going to fill in with instances of that report ID and @date. And that's how we do a GraphQL query on the bottom. And you can actually mix and match. You can mix and match FedEx. You can mix and match GraphQL with SQL, with RDF. You can do all sorts of interoperability queries. In this case, we're asking, we want a building which is lower than 100 meters and is built later than the 1990s. And we want information about its ID, location, built on, about the nested object inspection, which is related to that building. We're interested about the ID of the inspection and date. We're also interested in how tall the building is. And then this GraphQL query will get translated to a SPARQL query, which actually optionally can get translated to a SQL query if we so desire, and if we leave our database like that. Finally, I want to talk about showing our work with visualizations. GraphDB is not primarily a visualization tool, but it does offer the visual graph, which is this visualization of things with nodes and edges in a colorful graph, which can move around and expand edges and put up labels. And that's a decent starting point. What we have often seen and what we use internally for some of our solutions are Jupyter notebooks with Python, because they are relatively versatile and easy to set up. And again, as I was mentioning back earlier, data analysts, they love Python because it's versatile, easy to pick up language, and Jupyter notebooks are a great tool for that. And Elasticsearch connectors and Kibana visualizations. And Kibana is on the other hand, because Jupyter notebooks, you still need to know Python and the libraries. But with Kibana visualizations, which are less flexible than Jupyter and Python visualizations, Kibana, you can set it up without knowledge of how a programming language actually functions. And Elasticsearch connectors, in GraphDB, there's the connectors functionality, which allows you to index some data in secondary stores, in this case in Elasticsearch. So you have your information and you say that some specific fields, you also want them to be in Elasticsearch. This also works for Soar, for Kafka, for Lucene. And yeah, those are the 4 options actually. Oh, and there's a MongoDB plugin, which allows you to interact with MongoDB, but it works a bit differently. That's how you create a connector. I could have shown you a visualization, but visualizations, there are so many different ones that it's almost pointless to show you how it looks like specifically. But this is something quite specific to GraphDB, how you set up a connector. I'm going to say that an Elasticsearch node, it's located at Elastic Inspections 9200. This is assuming probably a Docker deployment. I'm going to index the building type, and I'm interested in the latitude and longitude fields. I'm going to follow this property chain. So each building has a location, that location has a latitude, and that latitude is some object. So in what I'm going to have then in the database is some ID, which is the building ID. Then it has this latitude property, and the latitude property relates to the object which is at the end of this triple building location latitude object. The same goes for longitude, and you can also have filters. So maybe you want to only index in Elasticsearch buildings which are in the outside of the power circle, or the reverse, only inside the power circle. So all possible. And that's our model. And this comes back to our revolution versus evolution idea. So if you go to your company and you say, okay, I want to do building inspection, that's what I want to do. And they've never done that in this way. They don't have the know-how. You give them this, people will be terrified of that. They're going to turn around and say, okay, we can't do this. There's just too much. Or that's too big of a time investment. But if you build up gradually, if you start at the analog, move through digital format, put in SHACL when needed, put in a visualization when needed. Maybe you want to insert some SQL data as needed. Again, if you're building gradually, then this change will be gentler. You not waste effort, and you not alienate people. It's all about gradual building. It's all about evolution over revolution. And actually, in this regard, and in regards of how we're going to build our complex data, we are going to deploy another webinar in, I believe, 2 weeks or so, which is going to be on how to do complex data, how to do nested statements with SPARQL Star, because property graphs are another option where you have very complex edges. So we have two nodes, there's an edge between them, and you have very complex edges with a lot of metadata. We're going to show you how to do that with SPARQL Star and how to keep it in a semantic database, but this is going to be in a later webinar. And yeah, it's time for questions and answers. We have about 7 minutes for it. There's chat messages. There. And then there's questions.
Yeah, you can leave your question in the Q&A box in your GoToWebinar panel on the right. So if you have any, now is the time to do so.
Yep. There's some questions, but scrolling them is a bit. Okay, that's someone posting a stack trace inside. Someone was installing GraphDB Enterprise Edition, and there was a problem with dropping a repository. I would look at that stack trace and probably get back to you, because the way in which it gets posted in here, it's quite problematic in terms of the actual visualization of the question. But yeah, we will check out that stack trace and we'll write you an email. Select previous answer. Actually, I can. Yay! I found out how to pop them open. Sorry for this. I'm struggling. I'm just enlarging the question. No audio. Yep, that was fixed. Apps on Android, that was fixed. Have already tried before. Can we do mappings from MySQL to Ontology? Yes, you can. that's the first sort of question which we can offer, which we can answer right now. SQL to the ontology, it's distinct, the on-top mapping for RDF. You can do that with R2RML, which is a relational mapping language, or you can do that with with an OBDA. I believe was the term, which is this specific mapping language, which is about more easier. It's easier than R2RML, and it's what we prefer in our examples. And actually, I can send you the link towards that that documentation. So just a moment. It will be virtualization. There, it will be present in the chat. There we go. There's another question. Combining the last complex picture with AI, write AI in the topic and everything. In terms of the last complex picture, yes, there are bits and pieces where you can use machine learning and AI. You can use machine learning and AI if you want to plug it in. You can use it in, for example, optimizing the ETL process and making sure that things map to their proper op types. You can use AI in terms of reconciliation if you have strings and you want to turn them into RDF data and IDs. You can do that with AI there. You can, I suppose, do some analytics, and this is actually the strong suit of AI. I mean, AI would be best at doing analytics of what we already have in terms of visualization and so on. What challenges did we experience designing the ontology and data schema? Well, in terms of moving forward from SQL databases and RDF database, it's very often the question about how are things going to change over time, because when everything is static and we just have those specific models and we can use them, then that's easy. But what happens when you start replacing things and breaking all things? And very often this is done with expressive mapping language, with an expressive schema, which take the time and plan out and take great pains that you have deprecation planned there. And again, sometimes another problem is performance, and very often it's the case that performance heavily depends on what the SQL database is and optimizations in the JDBC and the driver, which translates the queries. Okay, what kind of complexity do RDBMs mapped queries offers? I believe on the bottom of the virtualization there are some limitations. So, for example, if we're talking about virtual queries, well, that depends if there is a index to the underlying storage. Sometimes it will be slow to answer specific queries. It's not possible to have auto-suggest and auto-complete. You cannot have graph traversal. So in Gradwin 9.9, we released the graph path search algorithm, which allows you to follow the path of some predicates to some data, but that actually depends on data which is stored in memory, not in memory. So that depends on data which is stored in the system, like persisted in Graph. You wouldn't be able to do that. But in terms of optional, bind exists. That's all possible. That's all possible. Why is the take-up slow on graph databases in SMEs, when large companies have been using it successfully for years, well, it requires some upfront investment in terms of know-how. It requires you to know what graph technology is, how it works. There's less tooling around it, simply put. If you use SQL, there's many more tools, but many people don't need specifically graph technology, and they want something specific. And Google and Facebook, they're graphs by nature. Facebook in particular, but Google also as well. And they're very well suited and very specific use case, which works really great with graph databases. And this is why I believe they've done graph databases early, whereas others have done it late. They have a lot of resources to spend on it, and they have a natural model which works with it. Can you do mappings from XML to yes, you can do mappings from XML to ontology. You can do that with the OntoRefine. There's a capability for that. Can very easily do that actually. Yeah, I believe that this covered actually all questions, and we are a bit over time. Thank you a lot for your time, and I'll probably give and it's been great hearing all of your questions and giving you the answers. And I'll give the stage to Yasin to close our webinar. Who is muted?
Thank you very much, Rado, and thank you very much everyone who joined us today. I will send you the recording of this session tomorrow, so you will be able to watch it at your convenience if you'd like. Also, I will attach the slides from today, so you will have that as well. Let me just plug again that in 2 weeks' time we'll have another webinar with our CEO, Atanas Kiryakov. I already sent the link in the chat, so if you're interested in that, you can go and register now. With that, I'd like to close this session. Thank you again very much, and see you during our next webinar. Bye-bye.
Goodbye.